Hey guys, today we're going to start our stoichiometry. We'll give you a good example here to go ahead and get to explain how to do stoichiometry in what I feel is one of the easiest ways. It's not that hard. You just got to start at the beginning, use the things that we've known, that we've done up to this point, and then put them all together to do this problem. So what we're going to start off, we're going to do mass to molar ratio to mass. Now, we could put mass, volume, mole, any of those things right here, but we have to convert from one compound to another. So again, we're going to do stoichiometry with Mr. Nelson. So we're going to start off with our first example problem that we have. So it reads, tin metal reacts with hydrogen monofluoride gas to produce tin 2 fluoride and hydrogen gas. And the second part of the question is, how many grams of hydrogen monofluoride are required to react completely with 75 grams of tin? Now that's the question that we really have to answer. So before we can answer that question, before we can get from 75 grams of tin to how many grams of hydrogen monofluoride, we have to balance the equation. So the first thing we're going to do is balance the equation. We have it in a word equation, so we can go ahead and do that. So we have tin. Well, what is the symbol for tin? The symbol for tin is just SN. Now I have a little line at the beginning of each one of these because that's where we're going to put our coefficients at the end. So after we do this, it reacts with hydrogen monofluoride. Now, yes, it begins with hydrogen, but it is a gas, so it's not an aqueous solution, so it's not an acid. So we're just going to follow the type 3 rules. So hydrogen monofluoride means I have one of each one. Okay, and that produces the same thing as yield, tin 2 fluoride. So the tin has a +2, the fluoride has a -1. We crisscross those, and we end up with tin or SnF2. And then that's going to have hydrogen gas. Now I could just put H down, but H would be wrong because remember, hydrogen is a diatomic element, so it's one of the two. Now we have our skeleton equation. So what do we do next? We have to balance this equation. We've already talked about balancing equations, so the first thing, if you remember what we're going to do, is we're going to put down our symbols of each element that we have. So we have tin, fluorine, and then hydrogen. I always like to save hydrogen to the end, so that if we can do that, that's what we're going to do, especially since I have it over here. But because I have tin all by itself, I can put any number in front of coefficient. So the next thing that we're going to do is we're going to write down how many of each one we have. So over here, there's no numbers, so we end up having one tin. Fluorine, we have one fluorine, and we have one hydrogen. On this side, we have one tin, we have 2 fluorines, and we have 2 hydrogens. So we said we're going to save hydrogen to the end, so we're going to work with fluorine. So the first thing we have to do is we have to change. We can't change any subscripts. We can only change coefficients, so we can change what's in the blanks. So we're going to go ahead and we're going to put a 2 right here, which now means that we have 2 fluorines. So we're going to change that. Okay. And we're going to also know that we have 2 hydrogen gases now. So we're going to cross that out. And now when we look at that, by doing that right there, we have a balanced chemical equation. Pretty simple one to get that balance. But what do we also need is we need that molar ratios. So here's our molar ratio. It's going to be 1 to 2 to 1 to 2. So we're going to use that molar ratio to convert from 75 grams of tin to how many grams of hydrogen monofluoride. So in this question right here, we're always going to have to start out with what we have in the equation. So we're going to start out with our 75 grams of tin. What do we do next? It's one of the always things. When we convert, what do we do next? We're going to convert this to moles. Okay, we're doing that so we can use our molar ratio that we got within the balanced chemical equation. So we're going to put our handy dandy times in a line, and then we're going to put our grams on bottom. Now our grams on bottom, we have to put our molar mass in grams in order to get moles. So we're going to put 119 grams. Now where do we come up with 119? Well, that's how much 1 mole of tin weighs. Where do we get it? From the periodic table. Okay, and we know that 1 mole of tin, the molar mass of tin, equals 1 mole. So we put that on top. Now we go ahead and put our times in a line again. And now I got to convert from moles of tin to moles of hydrogen monofluoride. So we're going to figure out how many here. So we have 2 there. So we're going to put this on bottom. We have to get rid of moles of tin. So we're going to put 1 mole of tin on bottom. And we're going to put the molar ratio for hydrogen monofluoride on top. So that equals 2 moles. Next thing we do is do our times in a line again. And now we got to get rid of moles of hydrogen monofluoride and change it back to grams. So we're going to put moles on bottom so we can cancel that out. And then we'll put grams on top of hydrogen monofluoride. And again, that's the molar mass of hydrogen and fluorine. Fluorine was 19, hydrogen was 1. So now we have that. Now we can go ahead and cross out all of our things that we have to. We get rid of these 2, we get rid of these 2, and we get rid of those 2. Now I'm left with grams of hydrogen monofluoride. And if I look at it, that's what I'm looking for, grams of hydrogen monofluoride. So all we have to do at this point is do the math. So we're going to take 75 divided by 119, multiply it by 2, then multiply it by 20. We didn't do any of the ones because the multiplying or dividing by 1 doesn't change the value of anything, so we don't have to put that in the calculator. So when we do that, the calculator says that we have 25.21008 grams of hydrogen monofluoride. But we're not done. That's how many grams we have. We're getting there. And so what do we have to do? Well, we have to figure out what is the number of significant figures, and that's what we have to put in. So we have to round to the correct number of significant figures. So what is the correct number of significant figures? We go back to the original problem, and I have it right up here, 75 grams, which are 3 significant figures. Remember, this 0 is significant because there's a decimal in the number. Trailing zeros are significant if there's a decimal in the number. So we end up having 3 significant figures. So what do? We take this number that we got in our calculator, and we go ahead and after the 3rd significant figure there, we go ahead and we draw a line. Then we look after the line and we see that this 1 tells us we're going to drop it off. And so our final answer is going to be 25.2 grams of hydrogen monofluoride. There you did it. That was a good example of a stoichiometry, going from mass of one compound, in this case grams of tin, to how many grams of hydrogen monofluoride. That's it. It's the end. Look for another example online or some of the suggested videos that I put in there. See you guys later.